Hi everyone, the topic of the day is rebindable syntax. This is a GHC extension that changes the meaning of lots of constructs in Haskell. And so today I just sort of want to give an introduction to this and show all of the different constructs that are affected. So let's dive in. Normally in a Haskell program, if I say something like x equals 5, well, here, that's not very helpful. It's saying that x is integer. Let's do something slightly different. Let's say fx equals x plus 5. The reason that it was inferring integer before is because of this monomorphism restriction thing. Let's just not get into that. Instead, if we have a function here that does some numerical manipulation, Haskell has overloaded numbers. And so that means that the inferred type of this is going to be, this is a function from any type A to back to that same type A, as long as that A is a number type. That's what this num_a constraint means. What's happening under the hood here in particular around this 5 is that this 5, it uses a method inside the num class to convert from integer, sort of the built-in type, to whatever type we have for A. So specifically, let's just take a quick look. There's a function from integer. And so from integer is this function that takes, for any num_a, for any a that's in the num class, it converts integer to that. And so that's what this 5 over here means. It means convert 5 to be in that type so that we can then add it to x. So I said this is about rebindable syntax. So let's turn on rebindable syntax and see what happens. So now our nice program becomes erroneous. And we get sort of this funny error here. We see not in scope from integer. The reason that this is, well, there's many reasons that this is strange, but the first is that from integer doesn't appear anywhere in our program. Instead, it just says that this thing isn't in scope. So that's one thing that's strange. The next thing that's strange is, well, we should think from integer should be in scope. From integer is in the prelude. So the first thing to know about rebindable syntax is rebindable syntax implies no implicit prelude. And that's because rebindable syntax is useful when we want to change the meaning of Haskell programs. So usually when we're sort of changing ordinary syntax, that means we're doing something slightly strange, and probably the prelude isn't going to work out very well for us. But we can always import that manually. So if I say import prelude, now everything is okay again. It's going to use, it's going to say that it's going to know where from integer comes from. But actually, I don't want to import prelude. I want to study this a little bit more, because actually, let's turn off rebindable syntax again for a moment. And instead, we'll just turn on no implicit prelude. And here, we get a different error. Now we get an error saying that we don't know what plus is. So let's fix that by, we'll import plus specifically. And now everything is good again. So we see here in the inferred type, instead of just saying num_a, it says ghc.num.num_a, and that's because num isn't in scope. So we need to give a fully qualified name for num so that we know really where it comes from. But we don't have any errors. This is still a valid Haskell program. So now let's turn on rebindable syntax again. And then again, now we see that we have an error here, and it still says not in scope from integer. So it does say that we can import that from prelude, but actually what will happen is that with rebindable syntax on, we use whatever from integer we happen to have in scope. But because rebindable syntax affects my whole module, I actually don't want to try to define from integer in this module, because I want to define that without all of this weird rebindable syntax stuff. So let me make another module. Let's see, how can I do that? I need to pop over here and then new file and then no rebind. We'll have this over here and then maybe that can be there. Yes, good. Okay, module no rebind. And so here I can write a from integer function, but I can do anything I want here. Well, I shouldn't say anything I want. From integer is always going to be applied to an integer. So this needs to take an integer to something, but oh, let's say I want this to be an integer to bool. Why not? So from integer, I can actually define this just to be an even test. And then we export from integer. Nice to have explicit export lists. So, it's going to compile. So, interesting. So down here it doesn't complain because both of these lines define a function from integer. This one complains because now it's not sure, am I trying to re-export the prelude from integer or this local one that I defined here? So I can disambiguate. Actually, I am going to do it this way. I'm going to say no rebind.from integer, where I have to use the same name of the module here, and then that's now no longer ambiguous. Okay, so now over here, if I import no rebind, well, now we see that there's this long sort of prefix here because bool isn't in scope. Let's just bring bool into scope because that's going to be good for us generally. So now f is inferred to have type bool arrow bool, but we're going to see here that plus, there's no instance for num bool because it's still the prelude plus. So let's get rid of this plus, and we'll just say x equals 5 now. And we can see here that with rebindable syntax on, x has type bool, and that's because we're using this from integer that's being imported over here, and that always returns a bool. If I change this to be something else, and now this is a car because this from integer is being applied to that 5. So this is useful, again, if we're writing some embedded domain-specific language or we're doing something really fancy that we want to have a different understanding of what number literals are. That's one of the really fun things about Haskell is that it's powerful enough to do that, to just change the meaning of numbers if that's what you want to do. Okay, so uses the from integer that's in scope for int literals. But it's not just integers. This same thing happens with decimal literals. There's the word I'm looking for. So if I say d equals 3.14, now I get an error saying not in scope from rational. So from rational is sort of an equivalent or a counterpart to from integer that works over rationals. So here I can say, let me just get rid of this type error. I don't like type errors. I can say from rational, again, this has to take a rational, and this one can go to, let's say it goes to string. From rational equals show. And that should work. We have to export it, so no rebind.from rational. And then now, this d equals 3.14 is inferred to have type string. And it really does. So if this is out of date now, so I can ask, what is d? It's, that's very interesting. It's not the string 3.14. It's this string because this is the show instance for rational prints things like this. So we probably don't want show because that's probably not what we want. Maybe we want show at prelude dot from rational, but I want that to convert into double, say. And then now we're going to need some type applications. Okay, so now if I do this and refresh, then we get 3.14. So we're taking the rational that GHC builds internally, converting it into a double, turning that into a string, and then we get 3.14 out. But maybe that's what we want to do because we're sort of playing around with syntax. So it uses the from rational that's in scope for decimal lits. Okay, that's some of what it does. The next thing that we're going to look at is string literals. So if I type a string literal, it just gets inferred to have type string. Nothing weird happens yet. But something weird is going to happen if I turn on overloaded strings. So with overloaded strings on, a string literal is the application of the from string function. And sure enough, down here, not in scope, from string. So now we can define from string over here. So if we say string, let's just say car from string equals hit. We're going to take the first character out. And then now, we have to export that. And now this type checks, and hello has type car. And so I can evaluate hello. And oops, what's going on here? Now I'm deeply confused. Expected file path. Expected file path? Why is that happening? I have no idea what is going on here. But my best guess is that somehow HLS's integration with GHCI might be slurping in these extensions and then it does weird things. So that tells me let's not rely on this feature and instead let's just create a little terminal window. I can do that here, but I don't want to be in subsumption. No, 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 no. I want to be in rebindable. There we are. Okay, so let's get GHCI going with rebind.hs. And GHCI by default doesn't slurp in the extensions that are here, so we're not going to have a similar weird thing happen, I hope. If I look at hello, it's the character H. Okay, so we're back on track here. So this is just using this feature over here, and as you might guess, if we have an empty string literal, that's still going to be inferred to have type char, but if I try to evaluate it, sorry, I have to reload, excuse me. If I try to evaluate it, then we're going to get exception because I've called head on an empty list. So here I can add with overloaded strings uses the from string that's in scope for string literals. But it's not just literals. We can go on from here. There's also constructs like if. So let's say we have, what letter I have to use? N. I don't know. If true, then 1 else 2. Well, now I get an error, not in scope, if then else. So if here is actually becoming a function call to a function named if then else. And it's just going to use whatever if then else is in scope. So I could do something interesting over here. I say if then else xyz equals x plus y plus z. That's a fine definition of a function. Let's export it. And then now it's saying, well, this is a function that requires a num, but it's not getting a num. So actually what I want to do is something like if 1, then 2, else 3. Of course, these are bools in this version. So let's change, oh dear. See, this is one of the challenges that comes up with rebindable syntax. Is sometimes you just want to use the built-in thing, but it's not very easy to do that. So what I can do is I can say, it's a little hard. I can't really do it. So instead, I'm just going to say 1, 2, 3 are all ints. And then they are what you think they are. And then we'll export them. And then now I can use them over here. 1, 2, 3. So this is one of the downsides of rebindable syntax. And this sometimes bites in practice in that when you want to just use the normal thing, you can't really. So you have to put it in another module that doesn't have rebindable syntax on. But now that I've done all of this, I can reload, all is well. What's n? It's 6. It's 1 plus 2 plus 3, even though there's this weird if then else, but I gave this strange definition of if then else over here. Okay, so let's see what else happens in rebindable syntax. Oh, let me put that in my little comment. Uses if then else for if then else. Probably the most powerful thing in rebindable syntax is what it does to do notation. So if I have some kind of action is do, let's say x is f of 53, and then I call y on x. I don't know, that looks like something kind of interesting. Well, let's see what we have here. So here, not in scope, bind. So this uses all of the sort of connective operators that we might use in normal do notation, but it just uses whatever ones are in scope. And so I'm not going to sort of build out a full example of this here. I'm going to comment this out. But we can see that this uses these operators, fail, that are in scope for do notation. And that's probably the most powerful one. It turns out that this is so powerful that some people don't want it connected with rebindable syntax because maybe you just want to do it for one do block and you don't want to affect all of your literals and all of this other stuff. So, but also see new extension, qualified do. designed and written by my Tweed colleague Facundo Dominguez. So qualified do allows you to say that just one do has different meanings for its operators. I don't want to get too distracted by that today, but if you're thinking about this just for do notation, you may want to think about qualified do instead. Let's see, what else can we do? We can do overloaded lists. So if I say L equals 1, 2, 3, that is just going to be a list of, well, why bool? It's bool because we're using from integer here. But if I turn on overloaded lists, then down here, we're going to get the familiar error, not in scope from list n. So the overloaded lists extension, if you give it a string literal, it actually passes the length of the list to the from list n function so that it can build the right thing. I can, for example, over here, do from list n. We're going to ignore the size of the list, and then we're just going to say that this is all. Oh, excuse me, not all. I meant and. So and is a function that will combine all of the elements of a list of a list of bools into a bool. The 1, 2, and 3 are going to be inferred to have bool here, and all I think I have to do now is export my from list n over here, and now this is inferred to have type bool. If I refresh and ask what L is, it's false because not all of the elements are even. If I change this to 2, 4, 6 and reload, then L is true now. And so this is using both the weird from integer and the weird from list n. For list literals. So there's a couple of different places. There's some other functions that are involved with overloaded lists, and they're all pulled from rebindable syntax. Because I don't want to get so distracted by writing out arrow code, which I'm not as comfortable with and as familiar with as some other parts of Haskell, but uses in scope names for arrows code, which can be very powerful. Arrow notation is very, very powerful. And so you can get quite far if you want to do something really crazy with arrows and rebindable syntax. So let's see, have I covered it all? Well, let's check the manual. So over here, this is the page in the GHC user manual that describes everything that rebindable syntax does. So we've seen integer literals and fractional literals and string literals. We have not seen this one. So when you have a pattern that has a number literal to the left of the arrow or left of the equal sign, then that uses an equality check. Well, now it's going to use whatever equals operator is in scope. If you're using n plus k patterns, which you shouldn't be because they were deprecated a long time ago, it'll use the subtraction operator and greater than or equals operator that are in scope. Negation, if you use a prefix minus sign, now it means a call to negate for some negate that's in scope. Conditionals we've seen, do notation we've seen, arrow notation we talked about very briefly, list notation we've seen. Oh, and then this overloaded label, this is a fairly new feature that means that every time if you have a hash mark and then some sequence of characters, that's going to turn into a call to from label. And that's a feature called overloaded labels. But when we have rebindable syntax on, it uses the from label that's in scope. There's more things that we could be doing. So for example, it says here that list comprehensions and mdo and parallel array comprehensions are unaffected. Presumably parallel list comprehensions are also unaffected. And case statements are also unaffected. We could imagine some form of rebindable syntax for these, but this is not currently part of GHC. So this has been a quick tour of rebindable syntax. I hope that this has been interesting. Thanks very much for watching. Bye.